Okay, this video is going to take a look at balancing a combustion equation, which can get a little tricky, so it might help to just have a specific example of combustion. Now, I'm going to start off by balancing this like we would normally, meaning that I'm just going to go left to right. So on the left-hand side, starting with our first element, carbon, I have 2 carbons. On the right-hand side, looking at carbons, I have 1 carbon. Okay, that means I need to increase the amount of carbons on the right. I'm going to do that by giving it a coefficient of 2. 2 times the 1 carbon that's there will give us 2 carbons to balance it out. Now if I move on to hydrogens, on the left-hand side, I have 6 hydrogens. On the right-hand side, I have 2 hydrogens. So I need to increase the amount of hydrogens on the product side. I'm going to put a coefficient of 3 here. 3 times the subscript of 2 for the hydrogens is going to change it from 2 to 6. So now our hydrogens are balanced out. Now the reason why this combustion problem is tricky is that we have oxygen in multiple locations in the problem. In other words, we have oxygen here, we have oxygens here, so we actually have 2 oxygens on the reactant side, and then we also have 2 oxygens on the product side. Okay, the best bet is to figure out, can I increase the amount of these oxygens right here and get everything balanced out? Because if I have to change the coefficients in front of any of the other compounds, I will mess up the balance that I've already created for all of the other elements. This one right here, this oxygen, isn't tied to any other elements, so if I can just change its number to balance things out, then I'll be home free. Okay, so let's take a look at how many we have throughout the problem. So in the first compound, I have 1 oxygen. In the second compound, the oxygen gas, I have 2. Okay, which means that combined total right now on the reactant side, I have 3. Okay. On the product side, I have 2 oxygens in the carbon dioxide. Actually, 2 oxygens in the carbon dioxide formula. However, I have a coefficient of 2. So that really means I have 4 oxygens, right? Coefficient of 2 times subscript of 2 gives me 4 oxygens. In the water, I have a coefficient of 3 times the invisible subscript of 1 there, which means I have 3 oxygens. So if we add that together, on the product side, we really have 7 oxygens. So the question is, okay, we already know that we have the lower amount of oxygens on the left-hand side, so we need to increase that. The question is, can we plug in a coefficient here that will bump it up to 7, okay, without needing me to change the first coefficient? Because if I change that coefficient, it's going to unbalance our carbons and our hydrogens. We're going to have to go back and do a lot of work. Okay, so by now, hopefully you've already figured out, if I plug in a coefficient of 3 here, that will change this to a 6, right? And then 1 plus the 1 over here, plus that 6, will give us the 7 that we need. And now we're balanced out. So the trick is, for combustion problems, balance this guy last. Okay, don't touch him until the very end, if you can help it, because you're going to use that to balance everything out without having to mess with the substances that you've already balanced. Okay? All right. Good luck on the test tomorrow. We'll see you guys tomorrow.